A 1 kg of a fluid at 30 bar 300 centigrade expand reversibly and isothermally to a pressures of 0.75 bar. Calculate the heat flow and the work done. There is two conditions: when the fluid is air, when the working fluid is steam. Sketch each process on a TS diagram. Okay, so the data that is provided in this statement, that is the pressure P1, that is 30 bar, temperature T1, that is 300 centigrade. Convert that into Kelvin, it become 573 Kelvin. And then isothermal expansion takes place and the pressure reached to P2, that is 0.75 bar. So first we will solve for the working fluid when there is a air. Then we solve for the working fluid when the fluid is steam. Okay, let me draw its TS diagram, because that is also asking in the questions to draw the proper neat clean TS diagram. So this is the higher pressure, this is the lower pressure. This is pressure P1, this is pressure P2. So from pressure P1 to pressure 2, expansion takes place. So it means that isentropic expansion has been taken place at a constant temperature. So that's why from process 1 to 2 we will consider temperatures constant, that is provided 300 centigrade, or you can say 573 Kelvin. Next we need to find the heat that is supplied during this process, and that is what we need to find: the heat flow and the work done. So we need to find the heat and the work done. So the heat that is equal to, that is supplied from process 1 to 2, is equal to RT ln P2 divided by P1. So what is R? That is constant, that is for the air 0.287, and what is T? That is 573 multiply ln, what is P2? That is 30 divided by 0.75. So upon simplifications you will get the heat that is supplied, that is 607 kilojoule per kg. And one more thing, it is obvious that when there is a heat supplied from process 1 to 2, it's obvious that it's an expansion process, because the pressure is reduced. So the work is done by the system. Whenever there is a work done by the system, it will take in a negative value. So the work done will be equal to the heat supplied, but in negative value, because the work is done by the system, plus change in internal energy. So in isentropic process the change in internal energy is 0. So the work done by the system is minus 607 kilojoules. So all the heat that you supply to this system is converted into the work done by the system. And these are our final answers. I hope you understand this part of the problem 5.10. Now further we will find the heat supplied and the work done by the system when the working fluid is steam. So stay tuned with us now. So from the same problem that previously we solved to find the heat flow and the work done when the working fluid was air, this time we are using the working fluid as the steam, and for that the pressure P1 that is provided and temperatures that is provided, we are writing it. Okay, so the temperature T1 is equal to T2 because expansion is taking place isothermally. We need to find the heat flow, so work done and the heat flow that is supplied, and also draw its process on a TS diagram. Let's see, this is the TS diagram. When the working fluid, remember that we are solving now for the steam. So if there is a steam, it means there is a dome curve shape available. This is the high pressure line. This is the low pressure line. This is the pressure P1, this is the pressure P2. So it is obvious that the expansion takes place from pressure P1 and reach till pressure P2. So it means expansion is takes place isothermally. The temperature is constant, that is provided 573 Kelvin. So I am writing here. The heat will be supplied to this system in order to get out of the work. Extract a portion of the steam table, that is our concern in this statement. So from steam table at pressure P1 and temperature 300 centigrade, you will see that the entropy S1 and enthalpy U1 is provided in the steam table. You can just write here. So U1, that is 2750.1 kilojoule per kg, and the entropy S1, that is 6.539 kilojoule per kg Kelvin. Remember, our state point 1 and 2 both lie in the superheated region. Now next is the at pressure P2, that is 0.75 bar, and temperature 300 centigrade, that is T2, that is the same as T1. You will get the enthalpy, that is U2, that is equal to 2811 kilojoule per kg by the steam, because that portion of the steam table I haven't found that. So you can search on Google, you can easily find on this pressure 0.75 bar. You will find the enthalpy value and the entropy value, that is our state point 2, that is 8.349 kilojoule per kg. So all the parameters for state point 1 and 2 has been determined. Now it is easy to find the heat that is supplied to the system, that is equal to temperatures and change in entropy, and that is further equal to temperatures S2 minus S1. So the entropy here is S2 and the entropy here is S1. So this change in entropy multiplied with temperature will give you the heat that is supplied to the system. So what is the temperature? 573. Entropy at state 2, 8.349 minus 6.539. The heat you will get that is supplied to the system after simplification, 1037 kilojoule per kg. Now from the first law of thermodynamics, the heat that is supplied is equal to change in internal energy plus work done. To the heat that is supplied minus change in internal energy. Okay, so the heat that is supplied is 1037 minus change in internal energy, that is 2811 minus 27,050. So upon simplifications you will get the work that is done by the system, that is 976.1 kilojoule per kg. But remember, here you will write the negative sign. Why? Because work is done by the system during this process when the working fluid is steam. So that's why negative sign is mandatory to write here. So these were our final answers. I hope you understand it. If you are still in confusions, you can ask in the comment sections. I'll make a separate video on that. Thank you so much. Please subscribe.